Hi there guys, so my next little project that I'm going to be working on is this Alpine 1983 12-speed drill press. Now I've already cleaned up the table and the base machine surface of the drill just with a bit of Scotch-Brite and some WD, but as you can see the rear column is still pretty grimy and rusted. So I'm going to strip the head off the machine, take the column off and the table and clean everything up and probably repaint the machine. At the moment, when you turn the machine on and try to drill, as you can see when I move the quill down, the pulleys themselves actually engage with the guard and are trying to wear through the paint. So I'm going to try and rectify this problem before it gets any worse, probably by just adding a little spacer beneath these pulleys, and then once that's sorted and the machine's reassembled, I'll use some new link belts to reduce belt noise and vibration on the machine itself, as well as hopefully upgrading to a VSD or VFD to adjust the speed. Depends whether I use the standard single phase motor or whether I change it to a 3-phase motor. So, gonna get at it, stripping the machine down. So, with the drill press stripped down, I've now got the main column shaft here in the Colchester master lathe. I've got a live center in the end there with aluminium nose cone just to make up the difference. Obviously not taking any heavy cuts, I'm just going to be cleaning up the shaft, so that should work totally fine. I'll get you set up on a time lapse and get this shaft cleaned up. Right then, so I'm working on my 12-speed Alpine drill press. As you can see here, I've got the table casting, the table support casting with the drive worm gear for the rack and pinion that runs up the column of the machine. Now obviously this worm is going in backwards at the moment, just to show you that there is a considerable amount of play within the original castings bore. So what I'm hoping to achieve is to skim the face of this so it's nice and flush, and then open out the bore to take a brass bushing that fits this worm shaft a lot nicer. The issue that I now face with this part, if I want to bore this hole here and skim the face, ideally I'd like to use a boring head for that procedure, but on the machine that I have with its current configuration, the available throat depth is not really going to give me enough to get the boring head in and the part and achieve what I need to achieve. So my thoughts are I'm probably going to have to do it over on the lathe, but with the shape of this part it's not going to be easy to get it secured. But we do have this register face here with a stud sticking out that is where the table secures, so I'm hoping to be able to secure that at 90 degrees to the face plate and get a few clamps on it here and there, and obviously center up to that bore. Right then, so we're over at the Colchester Master roundhead lathe. This is the setup I believe I'm going to use for facing and boring out this casting for my 12-speed drill press. As you can see, I've had to use a parallel along the center of the faceplate to bridge the bore in the center to support the casting, and then on either side I've got some clamps set up. As you can see on this side of the casting, it's split to clamp the column, so I've used some shims into the split, and then just some mill tooling just holding it down to the faceplate there. And then on the other side we've got this machined surface, which is where the table pivots, so I've used that as a reference surface to be able to get a 90-degree fixing to keep the bore running true. And I've had to pack that spacer up a little bit on this side just to get it all leveled out properly. But I'm pretty happy with how it's looking. Now the bore itself is slightly oval, so the dial indicator doesn't really give a true reading, but I'm pretty pleased with how that's turning. You can just hear the pinion gear inside there clapping around. I think I'm going to try and wedge that with some blue roll so it's not clapping around, and then we can get on to skimming the face off and boring out the pinion bore. Just trying to shove some blue roll in between the gap at each side of this pinion gear here, just to stop it clattering around while I'm running the machine. But I also don't want it to get in the way of the bore and catch on the tool, so see how that's gone. There we go, no more clapping now. The gear is stationary inside the casting, so I'm pleased with that. And with this setup I'll just be taking very light cuts just to clean up the face and the bore, ready for a new brass bushing to go in. Right then, so we're going to set to skim the face off this casting here and then take out the internal bore to a larger diameter to suit a brass bushing that I will make to suit the part. So I believe on me scribblings, I think I've penciled down taking it out to about 13.5 mil the bore, and then I'll make a brass bushing and match that to the worm shaft of the drill press. So to start off with, I'm just going to touch off on the face, and I'm going to take off, you know, a couple of tenths. So I'm touched off there, just going to run very gentle because we're running so slow, using an aluminium insert just to give me a nice sharp cutting edge. Touching off there. I use the power feed to feed in and face this off. So, with the rough casting now faced off to a nice surface, nice shoulder, I will then bore out the centre to 13.5 mil to receive a brass bushing. Alright then guys, so over the past couple of days I've been brainstorming, trying to figure out how I could improve the angle adjustment on my Alpine 12-speed drill press. So I've came to the conclusion that I think I should be able to cut a gear, a worm gear, into the main casting of the table support Right then, following on from the previous videos there, I have now got the mandrel turned down and welded onto a small, well, a 15mm bar. So it's now in the tool post to give me adjustable height and depth of cut while I perform this procedure. So the procedure I'm hoping to achieve, as you can see, I've got an M12 1.75mm metric tap chucked up in the lathe there. I have seen this procedure done, but most gears they have cut have been brass, so it'll be interesting to see if I can get this procedure to work on some cast. So the part itself is now fitted onto a slip fit boss, and then there's a M12 stud sticking up through the center, and I've then used a thrust bearing on the top side along with some fiber washers to help stop the bolt, stop the nut trying to undo itself while I cut this gear. So I've eyeballed it, and I'm pretty sure that I've got it as close to center as I'm going to get, and I'm then going to make sure the part is as central on the tap itself as I can. It's hard to see with the casting how it is, but I'm pretty happy with where that's positioned. And then it's just going to be a matter of running the machine at a low speed and very slowly engaging the part and seeing if it will start to turn itself and cut the threads or gear teeth. So I'm going to be running this machine at its slowest speed to start, which is 54 RPM. Lock the carriage in place on the machine. So let's give this a go. I'm going to just wind the part in very, very slowly until I get a touch off on the part. Right, I'm starting to feel it touch there, so I'm going to zero out my DRO and just very gently So once I've completed a full rotation, I'm then going to advance my depth of cut gradually for a few rotations until I'm happy with how the gear teeth are starting to look. So I'm pleased to say that process has been a success, and I've managed to turn a worm gear onto the outer face of the drill press support casting. See if I can get my light in a bit of a better shot. As you can see, I've advanced the cross slide until I was in to a depth of 4mm, and I'm pretty pleased with how that's looking. The crests of the teeth are slightly rough, but for this application I think they're going to be just fine. Well pleased with that. Let me know what you guys think. Leave a like or a comment.